Hi everyone, Nick Smith here. I'm going to do a short video covering the usage of a new feature in version 2 of Lighting Reality, which is Australia and New Zealand standards. Now, I'm guessing if you've chosen to watch this video, it means that you've probably are fairly new to Lighting Reality, so I'm going to run through the whole process of setting up a design, and I'll use the Cat P category. So we have 4 calculation grids that apply to the Australian New Zealand standard 1158. We have the Oz version of Cat V and Cat P, and then we have the New Zealand standard version of the same. There are very subtle differences between the requirements, the way the calculations are carried out, and so on. I think in some of the New Zealand standards there's an extra requirement, but nonetheless there are very subtle differences. So that's the first thing that we need to consider, is whether we're designing to the Australian version or to the New Zealand version, and I'm guessing you already know the answer to that question without telling me. So okay, so we've selected that that calculation grid. The next thing I need to do is to go through and select the class I want to design the road to. As you can see, I've got all of the P classes that are available here, and I'm going to go select a Cat P3, hopefully so that will demonstrate something. So at that point, we can bring up a little pop-up box where this ANZ button is here. We've got a requirement box here which gives us a little reminder of the quality figures that we're actually aiming for in terms of equipment, light levels, and the various quality figures that we're actually aiming for. So the next thing I need to do is to go set up the road geometry. I'm going to assume in this case that we've got a 10-meter wide road with 2 footpaths. That's the way we set up calculations in the UK, is that we have a footpath and a road or a carriageway all lit to the same level. I don't know whether you do that the same in down under, but the next thing we're going to look at is the height. That's the height of the column that we're going to put the fitting on, in this case 6 meters. The tilt, whatever that happens to be, although if you're using an LED fitting, why do we even need to tilt a fitting? The spacing, I'll come back to that in a little bit, but if you know what the spacing is, you can go put a value in of say 40 or whatever the value happens to be, or you can leave that alone and we can optimize the design. I'll come back to that in a second. So the next thing is the setback, and this is the position of the column relative to the back of footpath, and you will see as I move the setback back, the circular part, the column part, moves to the back of the footpath. The outreach is the dimension from the center of the column to the optical center of the lantern. I'm going to set that at 0.4 because we're going to use a smallish lantern on this. And then we can look at our arrangement, whether we're going single-sided left, single-sided right, opposite, staggered reversed, or twin central. Clearly if you're using twin central you probably wouldn't on this type of road. I'm going to go with a single-sided left for this for now. The next thing we need to consider is the maintenance factor or light loss factor, depending on whatever you refer to that as. I'm going to set that at 0.76. And we can then go through and choose our luminaire. Now we have a number of products that have that are a part of our Lighting Reality database, and we can go through and choose a particular product. I'm going to use a DW Windsor lantern, in this case 3000 Kelvin, and I'm going to go for a D optic. Okay, so in this here I've got a whole bunch of different files, and there's a couple of things I can do at this point. Now it's possible that the photometry you actually want is not here. We can browse to that data. There is a separate video that I'll put in the comments below as to how you actually go load that data in. But basically you select browse, go to wherever the folder is, but there's other facilities that we have within the program to be able to do that. So we can select a fitting and we can look at the polar curve. It gives us information about the distribution. So we also have a Cartesian curve and an LCS diagram as well, which just shows the photometry in a slightly different way. LCS is something that comes out of the American standard, when we did the work on that, I thought it didn't do us any harm actually continuing to include that, so it's quite useful information. So what I can do at this point is I can go look at an image of the file. I can also look at the actual photometric file itself if that's what I want to do, we can also sort this information in various ways. So we can select the flux to sort it from low to high or from high to low. We can sort it by the product name, product type, by lamp, or what have you. So there's some other facilities in this in the middle toolbar here, which I'm going to come back to in a second. But I'll turn for now on the results and the points so you can see what's going on with that. So I'm just going to make that a bit smaller, put that up there out of the way. And then what we can do, if you know the fitting you actually want to use, and it may be you spin through some fittings and you actually find something that works for you, let's say that one there, then we can just go in and select opt, and that will then work out the spacing where that particular scenario actually works. Now at this point we have two options that we can do. At the moment I've got the calculation of EPV, the vertical illuminance, at the point midpoint in the thing. It's actually turned off, and it's turned off by default. I know there are some people who use it, and I know there are some people who don't use it. If you want to include it, you tick the box, and then whenever you optimize, it will include compliance with that 0.3 in this case as a requirement. In this case it's come up as optimization not possible with this luminaire. So if I turn it off and then optimize it, it will then give me a calculation. It will still calculate the EPV, but it will not include it as one of the target figures. Okay, so that's the simple way of doing it. Is to actually go and select the file. The alternative is that we click on the file and we select this opt button at the top of the Luminaire dialog box, and what that will then do is it will go through each of the optics that are available to us, and it will calculate for every single one what the maximum spacing that can be achieved based on the road configuration, the target levels that we've included. In this case we've excluded the EPV. And it will go through, and for each of those it will then calculate a solution that will work, and sooner or later it will get through all of those. Okay, I'm going to press stop at this point because I'm not getting any new data, which is useful. So all I've done there is, instead of sorting it by flux, I've sorted it by spacing. So it's gone from high to low, and you can clearly look down here and then choose a fitting either based on the spacing that you're looking for, or for that matter based on, because as you can see we've got a number of fittings here that have all got the same spacing at 56 meters, and perhaps you would go with the lowest flux value, which in theory is the lowest wattage fitting. In this case, this is that's the 30 watt fitting, so seems to work quite well. So that's the first option, is to use the Cat P. In terms of Cat V, it's obviously we calculate luminance. So same process is that you would select the grid, select the category you want to light to, you select the total width. So in this case I'm going to say put in 8 meters, the number of lanes, and if you want to zoom out and have a look at where the observer is, then we can do that as well. Set up the parameters. Let's maybe go with an 8 meter column, still 2 meters back. I'm going to use a bigger fitting this time, so let's go with an A optic in this case. And then we can go through the same process. And what we're now calculating is luminance. Those are the target figures we're actually aiming for. Exactly the same as before. We can press stop at any time, and what that will then do is allow us to go select the highest spacing and determine a solution that works best for us. It may be you want the best spacing, or it may be you already have an existing solution, and what you want to do is to go look at what spacing is going to work, what optic is going to work best for that particular requirement. And I think that we've covered all bases on the target levels. I would please ask you if there's anything you spot. I don't confess to be an expert on 1158, but if there's anything you spot that we're not doing, or something that we're doing that's not quite right, please let us know. You can drop us an email to support@lightingreality.com. And lastly, before I go, if you found the video useful today, please, if you can select the like button below, it helps us with our rankings within Google and YouTube. If you found the video useful, we publish new videos all of the time, so by subscribing you'll get an automatic notification of a new video, and hopefully that will be useful to you as well. If you have any comments, please put the comments below. I'll then get a notification that that's come through, and we can take a look at that. You can tweet us at Lighting Reality, or you can tweet me directly at nicksmith1246 through Twitter. You can send us an email to support@lightingreality.com if you have any questions or queries. Please subscribe for future updates, so when we publish new videos you get a notification. Thank you very much for watching, and hopefully I will see you in the next video.